A very good morning to one and all. My name is Ranganath Krishnan. I'm the Secretary and Treasurer at Bamboo Society of India. On behalf of Bamboo Society of India and Council of Architecture, I'd like to invite you all to this webinar series number 32. To take the proceedings forward, I would like to invite Architect Hemang to take the proceedings forward.
Thank you.
Thank you, Mr. Ranganath, to introduce me. So let us start with the webinar. Good morning, everyone. Bamboo is just a grass. It's a grass. It's a strong grass. Bamboo was traditionally used for building structure in different forms, ways, and methods in life. So structures like huts, gazebos, compound walls, fencing, roofings, etc. were done in the past. But do you know it has high tensile and compressive strength at a time, and that can be used as structural element? It has very different characteristics than other structural materials, not to compare, but it has its own advantages. Today, we are going to hear more about bamboo as structural element. I am architect and urban designer Hemang Mistry, member of Working Committee, Architecture Design and Civil Engineering as part of Bamboo Society of India. So we welcome you all to this webinar. So I request Professor Uday Gadkari, member of Working Committee, Architecture Design, Civil Engineering of Bamboo Society of India, who is also host of today's presentation, to start with the welcome speech. Over to you, sir.
A very good morning to you all, friends. Today is Saturday, the 19th of Feb 2022, and this is the day when we are now conducting the third of its kind webinar. It is the BSI ADCE, that is Bamboo Society of India's working committee, which is working into bamboo architecture, design and civil engineering branch. And we have been conducting many programs. This is the third of its kind on the webinar we are now today, hosting here. And it gives me immense pleasure to invite you all and welcome you all to this particular function. Friends, as I told you that Bamboo Society of India is an organization which began in 1989, and today we have more than 1,600 members across the country and across the world also. And its headquarters is in Bangalore, Karnataka. The chairman of this committee is Mr. Sridhar Kunathi. We will be joining us soon. But then we have Mr. Ranganath Krishnan, who is the secretary and the treasurer of this organization. And it is this particular headquarters or head organization which has made 5 working groups so as to deal into the various sectors and various aspects of bamboo. For example, we have bamboo cultivation group. We have now this architecture, design and civil engineering group. We have government schemes and projects under which one group is working. The skill development, capacity building programs also been handled by one group. Organizational activities is managed by some other group. And likewise, we have 5 working groups. We are one of them, and we are conducting this particular program in collaboration with Council of Architecture, New Delhi, the apex regulatory body of Government of India to regulate architecture and architecture education and architecture profession in this country. This particular body, we signed an MOU with Council of Architecture. BSI signed an MOU with Council of Architecture so as to carry out the researches into bamboo technology, bamboo engineering, bamboo science, and at the same time propagate them through the studies and academics to the students and all the stakeholders who are there in the bamboo industry. This is the purpose for which we signed an MOU, and that is why today we have Sapna ma'am, architect Sapna, the Vice President of Council of Architecture, who is also present here today. She has kindly consented to be the guest, and I'm sure that she would definitely have a dialogue with you soon. Talking, in fact, it would have been the introduction given of each speaker before before their speech follows. But however, it is my bounded duty to say that Sapna ma'am is one of my colleagues who has worked with me, who has been associated with me. And today she is the Vice President carrying out the duties of the Council of Architecture very diligently. She is here. About her detailed biodata we will come to know later. But we also have Mr. Ashwath, Dr. Ashwath, who has been one of our another speakers of another guest, chief guest of today's function. Then we have two experts, speakers rather, who would be talking about the engineering bamboo. Now, this is a theme which we have flown from the very first seminar, and that is rethinking bamboo in culture through design is the basic theme. Today's theme, last webinar was on architecture. Today's webinar is on engineering bamboo. And that is why we have these two speakers, Mr. Ashish, Dr. Ashish Kumar Das and Nilang. These are the two experts we have today with us, who have also a wide experience into the field of industry, building industry, engineering, civil engineering, design, etc., etc. And I'm sure that their speeches today would definitely be enlightening us about the bamboo and its very versatile characteristics, so as to use them even in the engineering as a mainstream engineering material. Friends, as a host, I welcome you all. I request that please be associated with this organization, become the member of this organization. It is a very good organization and probably the only national level organization, an age-old organization, an organization which has created its impact and trust within even the government, because most of our officers, office bearers are the highly placed officers, government officers, particularly in the forestry. So that is why we have to expand, we have to take bamboo ahead, and that is why this particular the occasion we are meeting here on. I once again welcome you all. I say very happy, healthy year ahead, and I'm sure that your contributions and participations in the activities of the BSI ADCE would definitely enrich our experiences. With these words, I will welcome once again and pass on the mic to Hemang for the further deliberations.
Thank you, Uday sir, for introductory insight for the session today. So now, may I call upon Architect Nilang Manjunath, Chairman of ADC BSI, a prominent bamboo enthusiast, to explain the theme. Over to you, ma'am.
Hello. Good morning, everybody, and a very warm welcome from Bamboo Society of India to each and everybody, and a very hearty welcome to Sapna ji, Dr. Ashwath, Mr. Nilang, Dr. Ashish, Hemang, and Ranganathan, and to all the other dignitaries that are here, Professor Uday Gadkari ji. Today's topic, I think we are here actually already spoke about rethinking bamboo through design to integrate into our culture. That was the topic. And in that, actually, we are doing alternatively, we have architecture and we have then civil engineering and then we have design. So the first one we did was on architecture with bamboo. And the second one that we are doing today is with engineering talking about the engineering disciplines that are working in the bamboo sector, and the third will be on design, and then again we will repeat. So we'll be bringing you, these seminars. And before that, we had done a webinar in last year in March on an overall theme on mainstreaming bamboo, and all this effort is towards mainstreaming bamboo in the building sector. Just a small brief about this concept that we have taken, and I'll be talking about from engineering perspective today. Natural organic materials such as bamboo actually have a very important and unique role in the effort to elevate housing and infrastructure problems, particularly in developing countries, because we have so much of bamboo. Their use is of a special relevance in the context of widespread damage and destruction caused by natural disasters owing to global warming. I think that also has become now common knowledge, which in part is attributed to the vast use of polluting and high energy demanding materials such as steel and cement. The application of non-conventional materials and technology is urgently needed to protect the environment and to establish sustainable development for the construction industry. And in this, mud and bamboo, they come as two major materials of construction, which were again, the major material of construction, or I would say a mainstream material of construction before the advent of steel and cement. So it's more like we are trying to, bringing future from the past. So bamboo actually shows an excellent potential for helping to solve many of the problems associated with the accelerated growth of world population. And after almost 4 decades of systemic research and development into bamboo, there is sufficient scientific information to increase the use of bamboo as a substitute for the industrial and polluting materials in many applications of the construction industry. And even though bamboo is a fast-growing, with all this, is a fast-growing, high-yielding, and easily renewable natural resource, our ability to use it in durable construction requires more research and development. The structural efficiency of bamboo compared to that of other engineering materials such as steel has been shown, but which may be attributed to the high strength of the uniaxial reinforcing fibers and the hollow cylindrical shapes of the culm. However, these characteristics, along with the geometrical irregularities of the raw material, pose challenges to develop efficient and cost-effective structural joints and other members. Now, with the available information, it is hoped that multinational companies which dominate the world's economy will not only think about their profits, but will also invest in low-cost energy-saving materials such as bamboo to contribute to a reduction in global warming. Let's just try to take just few topics that we'll be touching it, and there could be many more. One is a steel substitute that we are looking at. In addition to this, the major factors actually facing the development of durable bamboo constructions are the inherent weakness of the material, such as high water absorption and susceptibility to fungus and insect attack. Bamboo contains hemicelluloses, starch, sugar, and other lignin, which can be attacked by soluble extractives, preventing it from having a good durability characteristic. And this actually is a major drawback that has been there, and people have been trying to use, because of this, the concrete reinforcement that we try to do with bamboo, there's a lot of experimental investigations that have been done, and we will be bringing them to you in our subsequent seminars. And on the bond between bamboo and concrete, using linseed oil is one of the experiments that was shown to be effective and impose the bond between, it really improved actually the bond between corrugated splints and concrete. The pull-out tests also have been used to establish the bond between bamboo and concrete. So many experiments have been done. Then there's a strength grading, which also requires for proper effective, when we have to design, we need a strength grading. And that current design construction codes and standards do not contain so much of these procedures beyond cursory visual inspections, etc. And they present a research project using to develop a strength grading system for bamboo culms. These are really required to use it, without much hesitation, just like we try to use the other factory produced materials. Even with all this, bamboo has been indicated the most promising building material for decades. Technical, normative, and cultural challenges have prevented, as we know, about advocacy, about other things, it has prevented this widespread use of construction with all these things. So the structural use of natural bamboo in the modern age and proposes a new design and fabrication framework for high quality, sustainable and resilient bamboo structures for the 21st century. A lot of research has been being done by INBAR, and I'm happy to share that I am a part of the bamboo construction task force in the INBAR, one of the key experts, and there's a lot of good work which is happening there, and we will be sharing that with you in the subsequent webinars that we will be bringing to you. And laminated bamboo is another one, and there's a lot of work which is being done. So when we say engineering bamboo, it doesn't mean engineered bamboo actually, but laminated bamboo is like engineered bamboo. So we are talking about round bamboo and the other bamboo. So there's a multi-laboratory full-scale test programs need to be actually established to investigate the mechanical properties of these kind of laminated bamboo. Like the way they are doing testing for timber, CLT, we can actually have for even cross-laminated bamboo. And I think that would be really good to have it. Another area that we will be touching upon will be fire grading, which again is another problem which people think with the moment you think about bamboo, they think about fire. So we will be bringing you even topics and that. So this is what I just wanted to share. This is more like a prologue on the engineering side. We will be bringing you work done by engineers in these various areas for mainstreaming the use of bamboo through design of structures and the issues, various issues actually, and there are lots of them faced by them, which are also the learning, it has been a learning to them, and they will be sharing these learnings with you. With this, I welcome you once again, and I pass it over to Hemang once again to take the session forward.
Thank you, Nilang ma'am, for elaborative insight of how bamboo is used productively in the market these days. And thank you, ma'am, again. And now I welcome, so before that, due to some unavoidable reasons, Mr. Sridhar Kunathi, who is also a chairman of Bamboo Society of India, is not available here. And thank you for him to be a good support for us from Bamboo Society of India. And with that, followed by architect. Now we welcome architect Sapna, who is an architect from Chandigarh and also the Vice President of Council of Architecture. She has achieved numerous works in the field of architecture. She pursued private practice with her husband, who is an architect too, for 2 years. And after her marriage, and later she joined Department of Tourism, Haryana, as assistant architect, where she worked on theme-based tourist projects and did a lot of interior work. In 1996, she joined Department of Architecture, State of Punjab, as architect through PPSC. And in 2002, she got promoted as senior architect. And in 2012, she became the youngest chief architect of Punjab. She has been holding the post of chief architect for the longest spell in the department and making the department progress at the race to stand by the current. Thank you, ma'am. This is wonderful to have you here and with such a wonderful profile and achievements. Over to you, ma'am. If you can share insight for today's session. Thank you.
Thank you, Architect Hemang, and very good morning to everyone, and warm greetings from Council of Architecture. I'm glad we all are together here on this digital platform and discussing about a very versatile material, which is bamboo. We all know that India is the second largest producer of bamboo in the world. Despite this, however, the use of this material in the urban India's building industry has been negligible. We can say it could be lack of research, maybe willingness to innovate, and even more moving away from a conventional material. It is now time that we architects, engineers, and builders should explore this wonderful, eco-friendly, and very versatile material for its use in building construction. We architects and engineers are very well aware that construction sector is said to be the primary contribution in the increasing CO2 emission and global warming. But bamboo is one such material which is available in plenty, sustainable, fast-growing, and easily processed, and need a very minimal labor and transportation. And before starting this webinar, architect Hemang just mentioned that he's sitting under a bamboo structure which is 50 feet by 120 feet. So we can very well imagine that bamboo is such a material we can really bring into our construction sector and support the sustainability goals. And to even mention that the strength of bamboo is 2 times higher than concrete, while its tensile strength is close to steel. And we in Council of Architecture strongly feel that it's our role and responsibility that our fraternity, our society should be aware of the versatility of this material. And for this, Professor Gadkari ji very, mentioned in the beginning. And Professor Gadkari ji, thank you so much for your kind words too, that we have entered into MOU with Bamboo Society of India. And our main objective is to bring bamboo as a building material in the construction sector, and to establish research centers, testing labs, and even to promote bamboo-based design in academic projects. The government has directed Council of Architecture to include bamboo in architecture curriculum, and we are definitely working towards that. And we, together with Bamboo Society of India, we really want to bring awareness regarding this material. I know there's it was mentioned that this society was formed in 1989, and we have to really work towards this, and to even do more and more research on this material so that we can actually show our fraternity, our society, that definitely to increase their awareness towards this material, and bring it into the stream of construction sector. And for this, then now I would like Architect Nilang to take this forward, and this webinar, the Rethinking Bamboo Through Design Engineering Bamboo, to take this further. And I'm really looking forward to listen to the speakers who would share their knowledge, and all the best to the speakers. And thank you so much for giving me the opportunity to be part of this platform. Thank you so much.
Thank you so much. Thank you.
Thank you, Sapna ma'am. Ma'am, this came to an idea that if you can introduce in Chandigarh, this material as part of the government sector also. So likewise, placing into DSR.
Yeah, true. Yeah.
Or any of this building department, it would be a great initiative, as how Maharashtra has done earlier.
Very true, and Hemang, I'm sitting in a city where, it's built by Corbusier, and concrete is the main material, we always see around us. But definitely it's time we should bring this material being part of our, PWD, CSR also.
Yeah. Right.
Thank you so much.
Thank you, ma'am. Yeah. And thank you, ma'am, for the wonderful insights you've shared today. And now I call upon Architect Ashwath, Principal Director of Bangalore Institute of Technology.
Dr. Ashwath.
Yes. He has done Masters and Doctorate in Structural Engineering. He has been heading numerous technical organizations, including ACCE, Indian Concrete Institute, Bureau of Indian Standards. Over to you, sir.
Thank you very much. First of all, I should compliment both Bamboo Society of India and all the organizers of this program and the Council of Architecture for signing an MOU to do some research in this area, bamboo. In fact, we as academicians from many years, we are into this, and our structural engineering PG students and civil engineering students are taking up projects in a smaller scale. But focused research efforts are very much needed to actively encourage all the stakeholders to use bamboo very effectively. And in fact, there have been a lot of work even from the Institute of IISc, Indian Institute of Science, Professor Jagdish and others on various alternative building materials, sustainable building materials. So in that direction, there was considerable work in other materials. For example, river sand. Alternatives to river sand, lot of work has been done, and many alternatives have been proposed, and now it is a reality that the usage of river sand has been completely almost reduced, and the alternative materials are being used very widely. And similarly, as some of you mentioned, bamboo is one of the safe material, sustainable material, and a good alternative to reinforcing steel. And use of steel is very essential, but wherever possible, and for structures which are not very high-rise structures, bamboo can be effectively used. And in this direction, I'm sure both the speakers, Nilang and Ashish, will definitely show some light on this. I will not take much time in getting into, even though I'm a structural engineer, I will not get into their shoes today. My role as immediate past president of Association of Consulting Civil Engineers, which has got about 27 centers across India and more than 10,000 civil engineers as members, and other professional bodies from the engineering front, Institution of Engineers and Structural Engineers Association. There are a lot of associations are there. So whatever support is required, whatever activities are required through Bamboo Society of India, we will definitely be able to reach out to all the civil engineers and structural engineers. So I'll assure the support of professional civil engineers front, and since I'm also the principal of an engineering college, so we are in touch with almost all engineering colleges, and there are a lot of community, student community, both at undergraduate level and at postgraduate level. We have not been focusedly told them what to do in this direction. So this is the right time. I think many of you are taking a lot of interest, and we are also with you, and definitely we will take bamboo into all the civil engineering student level, so that when they become practicing engineers, definitely they will make attempts to use bamboo. In that way, we can spread the awareness and usage of bamboo. And I extend full support from my side. And one more thing I would like to mention is, as I mentioned earlier to Architect Nilang, the Bureau of Indian Standards is also very active nowadays, and a lot of efforts have been done by the immediate past civil engineering head, Sanjay Pant, and now he is elevated, but definitely we will have Arun Kumar in his place, and he will definitely support all of us to bring out small revisions to usage of bamboo as a structural material. So once the code comes in, then definitely the usage will automatically start in. Another way is we should somehow bring this material into the schedule of rates of various state governments, so that automatically the material will find a place for those who are interested to use. Otherwise, it is very difficult for major public and private buildings. So that is another area we can work on. So thank you very much for inviting, and a great future is there for this material, a wonderful material. And Architect Nilang, I know she's been doing a lot of work, and definitely we will be in touch with all of you and Bamboo Society of India. And I'm also eagerly looking for Nilang and Ashish to know more about the structural aspects of the material. There are already some codes are there for structural purpose, how to use bamboo. I think IS 9096 will give you preservation of material for structural purposes. There are many things out there. So thank you very much, and I wish this effort will definitely find active receiving from all the friends of stakeholders. Thank you very much.
Thank you.
Thank you, sir. Thank you, Dr. Ashwat, for the wonderful insight. And I think bamboo is a primary material as a structural element. It's very important to substantiate now for us, in the market, okay, so that we can grow ourselves, with a lot of beautiful structures coming up. Also, there are a lot of architects and structure designers who are really working hard for these movement. And within 10 years, one can see there will be a lot of beautiful structures will be coming up. Yeah, and thank you, sir.
Thank you very much.
And now, after seeking the blessings of the dignitaries present here, we commence with our first speaker, Dr. Ashish Kumar Das, to come forward and present. And so he is, Dr. Ashish Kumar Das is a doctorate in philosophy from IIT Delhi. He graduated in 2007 and did his master's in 2010. And interestingly, a PhD holder in 2017. That has added value to his knowledge, and I am sure it will help us in future too. He has done extensive knowledge on behavior and pattern of bamboo as material in different form. Let us understand from him about bamboo as a subject. Dr. Ashish Kumar, over to you.
Thank you, sir. Good morning, everybody. Am I audible?
Yes, please.
Okay, sir. Let me share the screen first.
Thank you.
Okay, very good morning to everybody. Myself, Dr. Ashish Kumar Das. Presently, I'm working as an assistant professor in Civil Engineering Department, MIT University, Gurgaon. Today, I will be discussing about the concrete wall panel as an effective walling system. So here I will be discussing about the bamboo, the potential, its property, then traditional walling material and bamboo-based walling system. Then case study of a 40 years old Assam type house, then casting and construction of concrete wall panel, and structural and non-structural performance of concrete panel. So, okay. So, the background of the work, I'll explain. The cement plaster bamboo based wall is very common in Assam and various northeastern part of India. However, this technology is rapidly getting its obsolescence. This research was initiated to establish a scientific knowledge that can help in acceptance of this technology. So, as the construction is one of the predominant sector in the developing countries like India, after agriculture. So here, wall in the building construction, the wall, which takes one of the important construction unit, and it consumes a huge amount of raw materials. So if I'll say the walling materials so far that we are using, that burnt clay bricks, fly ash bricks, hollow concrete blocks, fly ash bricks, autoclave blocks, and many more lightweight drywall partition system have come up. But all these walling materials usually consumes the non-renewable resource. So out of different walling materials, still burnt clay bricks predominant and it's dominating out of others. Even though we know that burnt clay bricks having different disadvantages. So we have to look out into some of the alternative, which is a sustainable alternative. So in this prospect, we cannot keep aside the bamboo. So as we know, there's a fast growing giant wood like grass and coming in the family of Graminae. So the availability of bamboo PLC, then it's widely available all across the globe. So especially in the higher rainfall areas in the tropical and subtropical zone. Even different bamboo species are available in very high temperature area at 40 to 50 degree, or even some species have found in very low temperature climatic condition. So as bamboo distribution, as we know that it is quite abundantly available in about 67% in Asia and Oceania, about 30% in Americas and the rest in Africa. Europe does not have any indigenous species, unfortunately. So bamboo distribution across India, we'll see. Then about 12.8% of the country's forest area is covered with bamboo. About 66% growing stock is concentrated in northeastern part of our country. And Mizoram is covered with 57% about its total geographical area. So if we'll see the features, as we know, it's a bamboo, which is column are segmented with solid joints called node. Between the nodes, the columns internode, and this column wall thickness greatly influence the bamboo's mechanical properties. So as we know, it is very good in compressive test. Also, we have found the value, it is even more than the normal concrete and about level of structural concrete, also good in tensile and flexure. So bamboo usage, especially in the walling system, it has a record history since long time. And as per the 2012 data, about 9% of the population live in grass, thatch and bamboo walled house in India. And about 65% in Arunachal and Assam, the population live in bamboo walled house. So bamboo is a wall construction material. It is used all across the world because of its special properties like lower modulus of elasticity, good ductility, and pliable, hollow, and lightweight, which makes it easy to make it the strips and weaving purpose. So if we'll see the bamboo-based walling system, especially it is broadly classified as permeable and semi-permeable. Especially technically, if I'll say, then it's plaster form and non-plaster form. Coming to the first non-plaster form, there are different kind of non-plaster bamboo systems, and weaving pattern are there, developed traditionally. So here it is one bamboo board which is used for the wall, and this is the chitra wall, which is mostly used in many parts of the world, across the world. The texture and everything depends on the skill of the artisan. And the prefabricated bamboo mat, which is the developed one, these are the prefabricated bamboo boards and the composite mats similar to plywood or particle board are mostly used. But it has been seen that unless and until it is protected by a long roof overhanging or away from the ground contact or painted regularly, these plastered bamboo walling system deteriorates rapidly because of its direct sunlight, weathering, and fungi or insect attack. So in contrary to that, the plaster form of bamboo, which is of different types, which is the improved version of bamboo walling system, this plastering makes the bamboo system better strength, robustness to the wall, also provide insulation and protection against the fire and weather. So these are the different types. Everybody be aware of this plastering form of bamboo walling system in the cramped wall system, which is practiced all across the world in different way. This is the mud field system where the studs are placed and the slats are attached and the space is being filled with the clay. the translation of the Barke system that usually we know. Then the wattle and daub system. This is the woven bamboo system, which is also known as quincha in Latin America. Then the bamboo grid system that is derived from the tendinous wall, where the steel wire mesh is covered and the plaster using the cement mortar. Then the flattened bamboo made with plaster. This is the flattened bamboo made with plaster. Also in the Chitra pattern, people are trying in the many part in the, but there the problem starts when the bond between the mortar is not interconnected from the both the side. So out of this is the developed form of the bamboo walling system in the plaster form that's widely adopted in many northeastern part in India. This is the bamboo wall in the Assam type house, and this commonly known as Assam type house, and this walling system is known as Ekra wall or Ekra wall previously, because it is a Ekra reed which is been used for the construction of the walls and roofs. And from that, this name has come. That usually this building, the bottom part is a brick wall and the top part is the above the window sill level. It is constructed of bamboo walling system. So this development of this Ekra walling system, or the change of this system, previously it is a wattle and daub system. This mud is replaced with cement plaster during the British colonial time. This system is known as bamboo concrete or bamboo. So where the concrete layer from both sides are interconnected through the gaps of the woven bamboo strips. And this system has practiced wide across the community in the different economical group of people with time. But unfortunately, this is in a phase of obsolescence, as modern construction is not paying attention to this. So for that, reviving this technology in a better and a modern way, we started work on this, and a case study of Assam house, of 40 years old Assam house was done. This was a 40 years old Assam house, which has been dismantled after that in 2014. And it was built in 1973. This is the supervisor's own house. He just spent his childhood days. So as we mark that in this kind of traditional system, there is no concealed wiring, which is one of the flaws. Then another flaws are there, the hanging and the roofs and the pictures, curtains, everything. Usually it is practiced from the battens. These wooden battens are the main load carrying member, and these partition infills are the bamboo walling system. So here in this wall that I found that untreated bamboo with thin irregular width bamboo strips were used. The mortar that has laid, it was the normal mason mortar. Sorry. Without adopting any design mix. The mortar that they are lying in the construction of the bamboo system, the casting, is the normal mason mortar. So durability as per the house owner, it has been understood that these panels had undergone no damage or any repair work in its lifetime of 40 years. There is nothing, any cracks or something visible. Only regularly it was painted, even though we know that Guwahati is coming in the earthquake zone 5. Even the fire, once devastating fire broke out in the year of 1992 and burned down the colony, which is 10 to 20 meter in a distance completely, but there was nothing absolutely happened to this house. So we started different experimental scientific validation of this. And as we know that partition wall member suffers from different kinds of loading during its service and needs to satisfy different performance, especially structural and non-structural both. So the impact test and the monotonic loading test, the static loading test usually, which is we consider for the energy absorption capacity of this Bamboo walling system. So in the both the vertical and horizontal impact testing with the hard body impact test. And we conducted the test on the existing 40 years old Bamboo walled panels. So here we use the hard mass of 5 kg and the length of the hanging mass was impactor was 1.8 meter. The weight and the height was decided according to the past studies. These are the results we got from the different test of panels, and these all are the single-based Bamboo panels constructed using normal masonics, and the average strength that we got 550 to 650 Zu. So after this test, which these are the fracture pattern of the test, and after this test, we started work on the laboratory level in the preparation of the panels, both small and large size panels, where the bamboo as a frame we first used, then the metallic framing with the twin leaf and the single leaf system, we started fabrication. After that, the techniques of making the corner panel. Then the casting work started. This casting was of different types. Firstly, we considered the normal masonics casting. Then the casting of the panels with the design mix of mortar. Using the design mix of mortar, we studied the rheology effect, and the casting process also been undertaken in the process of casting of the Bamboo panel. So the workability level, the admixtures doses, and also this work is now carrying forward the everything, the viscosity and this. So these are the different water cement ratio we consider from 0.4 to up to 0.7, and casting of the panels was conducted. In the process of casting, the manual casting, now we just consider the machine-based plastering process. So this plastering using the mortar spraying gun. So after this, the one house was constructed from the very basic level. These are the structural part where the bamboo columns were used. Then the panels were fabricated as per the dimension of the house is concerned. And finally, you can see this is the manual plastering was applied. And this is the house, that house we constructed. There are 6 columns are there, and all of the bamboo columns. And the fabricated wall panel were installed in their respective position using all these techniques of bamboo framing and metallic framing. And you can see after that, we found, we started to study on the panel technique, this bamboo panel technique in the RCC frame structure, how it can be implemented, and we started doing on that. And also this second house was plastered in the RCC frame structure and using the mortar spring. So in the twin leaf system, we solved the problem of the conceal electric wiring. This conceal electric wiring, which is quite difficult in case of the normal traditional Assam type house. So to take this technology forward, we just use this technique of using twin lip system and the wiring passing through this. And this is the house that I have already shown. And also we just nail insertion, which is a problem in case of normal motor mix. But in case of mixed design motor has enough strength to carry of the nail insertion and everything we studied. Then predetermined insertion of the plate also in the flat channel also we studied for the anchorage purpose. Then different parametric study in the fabrication process with the vertical number of vertical supporting strips with the non-skin and skinned strips weaving. Then the width of the strips, the effect of width of the strips in the panel strength. These are the different parametric study with also using different materials such as flowable foam concrete. Also we used to make the panel more lighter. It has also been studied. And you can see here in this picture, both single and twin mesh panels also cast using the flowable concrete, lightweight concrete. Also other material also we cast to study with the other material system with the bent walling system. So for the energy adjustment study in the impact, hard body impact energy adjustment of the panels, both drop bar and the horizontal impact study was conducted. These are the test results of the normal masonry mix motor cast concrete panel. So it was found that all the panels after being tested, it was the similar level of 650 to 550 to 650 level of impact energy absorption it's shown. So it signifies that usually the traditional process of concrete panel casting in Assam type house, it follows the normal mason mix motor. So after you can see this is the horizontal impact testing also conducted, and we found the level of the strength, it is quite similar whatever we found in case of case studies of the 40 years old house. So it is concluded that they are using the they have been using this normal mason mix. So after that we started work on design mix. This is the monotonic testing of the panels. This is the load versus deflection curve, and the non-skin strips fabricated panel shown very less strength. The variation of the species, different species also we tried. There is not significant variation we mark in the panel system, especially the strength carrying capacity when we consider the static loading test. So using the different design mix, we started different design mix from 0.4 to 0.7, and the panels were cast, and the impact energy study was conducted. And as we know that water to cement ratio at 0.42, it was showing the maximum impact energy absorption. Similarly, you can see over here, the strength of the panel got increased, and the energy absorption capacity in the monotonic loading is high when the design mix motor was used. And surprisingly, at 0.7 water to cement ratio also, it was found that more energy in the impact energy compared to the normal mason mix motors. So we can conclude from here that this normal mason mix motor is quite inferior even than 0.7 water to cement ratio. So after that, different panel that were studied at 0.42, especially we chose the 0.42 water cement ratio, and different panels were cast. Their results are these monotonic loading results. And it was found that these twin bamboo mesh panels, which was very much high, you can see it was about 12,600 103 joule of impact energy absorption of the twin mesh system compared to the single mesh concrete walling system. But the monotonic loading, when we conduct, the twin mesh system showed very lower level of energy compared to the single panel system, single concrete panel mesh system, because of the motor which is not interconnected from one side to another side. This might be the reason for this. So after that, different momentum, based on the momentum, different kind of panel we studied, different lightweight and heavyweight panels we compared with the concrete panel system. So this is the steel mesh panel system, welded steel with chicken mesh, then dry wall system, single fiberboard, double fiberboard panel system. This everything conducted with different momentum, with different heights. And this is the Drawbar Testing. This is the result we got. And we found that the concrete walling system, which is quite in the level of with the steel and different heavyweight walling system, the width of the panel definitely it's a governing criteria, taking care of the strength of the and robustness of the panel, and it is quite comparable with the heavyweight walling system that we walling panel system. Is the panel just like steel wire mesh or the welded steel mesh panel? We found the strength is quite comparable. So after that, after this test, also anchorage test we conducted. Anchorage test is very important as the lightweight anchorage pull down test and the heavyweight anchorage pull down test. That is the basin test. So we conducted the test to find out the strength of the eccentric loading strength of the concrete panel system. And this is the pattern we found. You can see that here the both single panel and twin panel we test. And from the graph, it was found that there is no displacement within the permissible limit. It was there, and there is no displacement what we found after the removal of the force. So after that, thermal insulation and the acoustic insulation non-structural study also we conduct to understand the behavior of this panel, especially the functional performance of this wall panel. So as we know, there are different hot box, hot plate, hot heat flow meter test or laboratory thermal insulation measurements are there using different standards. In this method, we followed the field thermal insulation measurement. So in the field thermal insulation measurement, heat flux method usually we used, and to find the thermal transmittance, the conductance of this concrete walling system. So as per the ASTM 1046 and the heat flux transducer we used from the in both sides of the panel, and thermocouple also temperature transducer also we used to record the variation of the temperature data. So this is the heat flux method where we used the as per the ISO 9869, and this is the laboratory setup for the thermal insulation study of the concrete walling system. And this is the result that we got, the variation and the flux variation with day and time. The test was run for 5 days, 6 days, 7 days like that, till we get the standard variation less than 5%. And this is the different U value. That is the watt per meter square Kelvin, the thermal transmittance value. And the concrete walling system, which is quite comparable with others, and it is in the range of the fly ash bricks, which is presently used. No doubt the burnt clay bricks having very less U value. But the twin system, the twin leaf system of the concrete walling system, which is very good thermal insulating properties because of the gap that exists between the two meshing system. So after that, the acoustic insulation study also I conducted on this walling system, and also compared with the brick wall system. And as we know that the sound attenuation or insulation is the reduction of the airborne sound pressure level coming from the source to receiver, which is very important for this wall system. So this acoustic insulation study was conducted to find out the sound transmission class. As sound transmission class of different material, we found as more the sound transmission class of the material is, the better is the insulation effect. So as per the ASTM standard E413, we just conduct the test for finding the single rating number, that is the STC. And this is the reverberation time calculation. As we know that reverberation time is the decay of the sound. It is the time to which the decay of the sound by 60 decibel in the level after the sound source becomes silent. So also we prepared the chamber of the concrete walls, both twin leaf system and single leaf system, to study the acoustic insulation. And this is the contour as per the ASTM E413 to find the sound pressure level, STC of the particular material at different frequency level. So these are the different instruments that are used, and acoustic testing was conducted. This is the equation to find the noise reduction and transmission loss as per the Sabin formula. Then sound attenuation of the brick wall system and other walling system. This is the reverberation time data. You can see that brick wall having the good reverberation percent lapse data. After that, the twin system, but the single concrete walling system didn't so as much good as double leaf system, but double leaf system of concrete walling system is quite close to the brick wall system. Although this brick wall was 100 brick wall system, full brick wall system. This is a noise isolation class of the material, that an IC value that we got of the W framed concrete walling partition. This is the reverberation time data. You can see that the reverberation time data is very less in case of brick wall system compared to the concrete walling system. So this is the STC. This is the STC test was found, and this is the STC data. And from this graph, you can able to see that the STC of the brick, even it is coming low compared to the W frame, that is the twin mesh system concrete panel, and it is quite comparable with the U framed and bamboo framed single mesh concrete panel system. And this is the conclusion that I want to highlight over here, that it was realized that bamboo strips are woven with small gaps in between the mortar. Sides get interconnected, making the system more robust and durable. Plastering the bamboo wall makes it more durable. When the plaster, the moisture content gets reduced to a very good significant level, which difficult to survivals of the termites. as we saw that 40 years old Assam type house without any deterioration of the inside bamboo, it was still lasting inside the plaster, even though it was non-treated bamboo being used, and use of also normal mason mix, it could last for 40 years. Even maybe it was quite intact properly the time of testing. So twin mesh system improves the impact energy up to a great extent in case of impact energy test we saw, but the energy absorption with static loading, especially monotonic loading, it was a bit less, and it is coming in the level of even it is less than the single mesh concrete panel system because of the lack of interconnected motor from both the side of the woven bamboo strips. The mixed design of motor over the traditional mason mix gives the concrete panel construction, improves the energy absorption capacity and characteristic. Thank you. With this, I'm concluding my topic.
Dr. Ashish, I would really congratulate you to present such a wonderful work and such a wonderful and tedious study you have been doing since quite long time. And I think this will help the entire fraternity to grow completely in a different way. So of course, there are a lot of traditional techniques where people have already done and we've been using it. But these are the tests. What you are doing is, I think it's there for the future.
Yes, thank you.
Yeah. So I request the members and dignitaries who have any questions for Ashish Kumar, he would be happy to answer you all.
Questions in the chat box, Hemant, you can pick them up.
I think good work is done by Dr. Ashish. The panels, Vampcrete, now most of the alternatives, what we see is plastering, even similar to ferro cement. You have a mesh of bamboo and plaster with cement slurry. Maybe we need to look at avoiding cement related materials and look at other alternatives so that it will be more sustainable. So
yes,
use
sir.
of cement to be avoided. Maybe I don't know whether you have done some work on
yes,
that
yes,
direction also. But we have tried here to avoid cement slurry. Otherwise, it becomes in line with ferro cement concepts. So maybe we can work in that direction also.
Yes, sir. Work is going on the, as even I have shown there that different design mix with different water to cement ratio we have tried using different industrial waste material also we have incorporated, and also work is going on since in the IT we are going on doing. Still I am in the touch and collaborating with the students and with my supervisor, and using different to increase the paste content, even the strength, whatever we are opting for, we should get with the uses of different industrial waste, with the different marble powder and the granite and also fly ash, and this we are incorporating instead of to reduce the cement content, so that to make this system more sustainable and better for the environmental friendly.
Yeah, that will be nice to know. In fact, in Bangalore, there are two institutions. One is RVTFAC and the other one is IPRITI. They are also trying some alternatives in this direction. And Jigani industrial area, very close to Bangalore, a lot of granite waste and marble waste materials are coming out. There are also some researchers are trying to use those materials to reduce the content of cement. Some of the works that are going in and around Bangalore. But definitely in the days to come, there will be a lot of alternatives, sustainable alternatives to cement and concrete. in this direction.
Yes.
Thank you. Thank you. Nice presentation, sir.
Thank you.
We have, Dr. Ashish, we have used mud, stabilized mud with this in the bamboo wall instead of the normal plaster. And my office has been around for now 10, 11 years. So, I mean, we have not done any testings, but we are actually using the building and we have no cracks. And a lot of studies by different students have come and done. They have not shared the results with us, otherwise we would have compiled probably. Maybe you can think about mud also as mudcrete,
Yes,
and mud
yes.
concrete is also an upcoming thing. And in that one can use all your lime and fly ash and other waste as stabilizing agents to take it forward. Maybe that could help instead of the cement thing. It could be working.
Yes, surely.
Just a suggestion. Just a suggestion. Yeah.
Surely.
Very good work, I must say.
Yeah,
I must congratulate. You've done very in-depth work. Yeah.
Thank you. Thank you.
One of our students also tried red mud plaster with some additives in this direction for the cement plaster, alternative to cement plaster, red mud plaster. In the village side, normally they do this only, red mud along with some other additives, village side additives. They use even jaggery and hay, all that will be mixed and they're built. So towards Kolar, KGF area, these kind of walls are even now available to witness.
Okay.
Hemang, Rutuja is also seen on the screen. Does
Yes.
she want to contribute something?
Yeah, please, Rutuja.
Sir, actually, I'm a B.Art student and I'm just learning bamboo techniques and everything right now. So that's why I joined the session and getting a lot of inputs from you all.
Do you have any specific question today to ask to the Dr. Ashish Kumar?
Sir, I was looking forward for the, are there any institutes in India where we can just go for the specifications in bamboo as a material?
There is no such that I will say that especially for bamboo there is institute, but in the IITs, all the, as I know that in institutes different research on the bamboo, both its structural application, non-structural, it's going on.
Okay,
Rutuja, even as far as my knowledge goes and my understanding, there is no formal full degree giving institution where the bamboo research is carried out. But we know there are many schools across the country where the practice of understanding and learning bamboo construction skills and techniques are there. In almost there are many schools, but at the same time there are many organizations and NGOs who have been running programs, academic programs and teachers training programs, building up the capacity building programs, and for the students, for the skilled labor, etc. There are many. I think Manjunath ma'am will help us definitely in procuring such a extensive list for the.
Okay, sir.
We have a course that is PG certificate course in bamboo application technology, and it's a year-long course on as home-based program, and we have been running it from 2011. You are all welcome to register for that for CGBMT. I will share the mail ID, and a lot of our people, the students who have come here, they have further gone on to do research. Some people are teaching in SEPT. Some people have gone on to start their own Vinay Kolte, Manu Narendran. There are many other people who have come here and they have carried on, and they have gone on to do research in the bamboo sector as well. So I will share it, and we coordinate with all these research organizations that we talked about, and try to put all that in the 1-year course that we actually do, which is with 2 hands-on workshops which happens at our campus, and one project of 2 months, which is at the end of the year. So that's a and it is done with Dalbagh University, and now we have also collaborated with the Rural University of Karnataka, Karnataka Rural Development Panchayat Raj University in Gadag, where we will be putting it up to PG diploma course is what the talks are going on, and probably take it further from there. So we are doing, so one can always get in touch with us.
Yeah. So,
I also appreciate that Samir Jamatia's videos are continuously being played right from the beginning of this webinar. It's a very nice ambience he has made, because when we're talking about bamboo, he is not seen on the screen, but demonstrating some works going on somewhere. It's a very nice thing. We appreciate even Samir's efforts.
yeah. So, Dr. Ashish, so I want to ask one thing to you. So you're here?
Yes, sir.
Yeah. So have you only tested these banked walls just on a panel size, or do you have also tested on the structures like arches, vaults, domes?
No. I have my work is now as a panel, means concrete walling system. I'm not working on the structural arches, means truss or anything. That is some. It is not my.
I mean, and the banked.
Yes. Also, we are working on concrete column system also. So
right.
Maybe future will get
So,
some good.
Following that, if anybody has more questions, yeah, please, Ram, go ahead.
Thank you. Ashish, yeah, it was a nice presentation. I was, impressed with a lot of details you pinpointed. The question is related to the bamboo framing. When most of the, previously mentioned, you mostly use concrete, you testings and everything on concrete, combination of concrete and bamboo, right? Yes. So here we, I have, been seeing that there is something called spray foam, which being used as, wooden walls. I'm from, Connecticut, USA. So here I see most of the walls are with the spray foam on the wood, okay, where I was thinking how the bamboo with the spray foam works. Will it be any way benefited? Like that, I was thinking.
Okay, actually, the test that we conducted with the double leaf system, double meshing system, there inside we have placed one of the figure that I had shown. We had placed the polystyrene sheet. So that is also one of the insulating effect for which we got very good result in the insulation purpose. Now we are working on that part. You used spray foam system, different glass wool and other material, insulating material. We are working on that in the double mesh system of the concrete walling system, so that to understand scientifically with the experimental and what is the real effect of the double mesh system using different materials.
Okay. In addition to that, my question is, you most of the testing you're trying to check the density of the wall, right? To dropping the ball and making sure whether it breaks or not, right? Or
no, energy absorption that.
Oh, okay.
And from the static loading, that load deflection curve, the energy absorption of the panel that we Yes.
Okay, so when I see the pattern in India, we check for the energy absorption, how strong the wall is. But here in European side or to a Western side, they more focus on sound absorption, in term not in the strengthen. So because here, if I knock the wall, you can hear, you can break it and go to the next room also. I'm not sure why we still believe in the, because inner walls can build, very in density wise with the less strength. That's my observation. But still we are, going through the, as you said, the weight and the density. That's what I observe.
Okay. So what you really want to ask is whether we are working on acoustic insulation. That's why we conducted that test. Means how much this traditional system is well insulating to the noise, airborne noise actually. And for that, the sound transmission class and the reverberation effect we studied, because the reverberation effect has that compared to the brick wall system. Now for the study also we are conducting to understand more on this acoustic insulating properties and thermal insulating properties conductivity of this system. So it is going on. So
yeah, my question is, are we still looking into that strength of the inner wall? That's my question. Which is not
definitely
major
partition wall should, there is criteria definitely SS Singapore standard some 9.7 something is there also is, so also British standard is also there. So in structural performance definitely impact strength must be, there is criteria is there. And also now I have not presented here, there is a another some test also already been conducted on the full scale basis of the impact resistance of the wall panel, which is the criteria given in the standard for the partition wall purpose. The what is the minimum impact strength it should bear up, and based on that the leveling of the partition wall systems are there. So it is coming quite good in the impact strength and means study, and also in the static loading monotonic testing also this Bamcrete panel system partition, it's coming very good. It has satisfied all the compliance criteria whatever presented in the standard.
Thank you, sir. And
we have done one foam panel construction in Rome actually in 2003 for a client, and we were supposed to do a prefabricated house for them, and we had made these panels for the Bamcrete wall, and we had sent, and he did not want the concrete construction, so we had a bamboo panel inside outside, and then we have this in between, we had put this foam out there because he wanted insulation. It was more, I think, from thermal insulation that he was thinking about, because it was in a remote area. I have no again, data is not there with me, but the client has been very happy from 2003, 4. I mean, I'm talking about. So they have been using the. I'm not aware about sound, but foam we have used quite a long time back, and it's been working very well in the climate of Rome with all the things. So no cracks, no nothing so far. So that's what we have done.
Awesome. Thank you. And another question related to that is most of the frames you are designing, or in this structure, is there any particular reason you the frame, bamboo frame, before applying the concrete, you mostly the frames are in this, what is, I don't know right word to find it out, or in this pattern? Is there any particular reason, or to hold the concrete only you have focusing on that?
That is also the fabrication process. During the fabrication process, firstly, when we made the panels of 650 into 650 square, it is quite easy to test those small panels. That's why we started working on the full-scale implementation of these panels. And for that, we developed different kind of framing pattern, especially as the traditional system uses timber, which is not environmentally friendly. That's why we go for the bamboo itself, and with for better simplification of the connection, we went for the metallic framing system. So in the bamboo framing system, it will tell that what crisscross of this strips coming from both sides, we just make a groove through the columns and leaving the nodal position so that the strips may go from one side to another all throughout. Firstly, we joined two separate panels. We found it is not aesthetically good sound from the real implementation point of view. After that, we dismantle again the installation. Again, we put the single bigger size diameter of bamboo so that the woven strips could pass through and through from one side to another. And it looks more better aesthetically, and also it was very good for the during the plastering also.
Thank you, sir. Thank you very much.
So, yeah, thank you, Dr. Ashish Kumar Dash. So he has done a phenomenal study in context to past and existing structures, testing of a lot of patterns of wall panels, deriving facts and figures through a lot of experimentation. This study is revolutionary and help us in future a lot. Your study has encouraged us to place ourselves in more details with the help of experts like you. Overwhelming study indeed. Thank you so much, Dr. Ashish, for spending so much time here and sharing your knowledge. So now I would like to welcome our second speaker, and also one of our dynamic structure designers in Ahmedabad, and now I think placed in Canada. So he's done his structure design and engineering, a graduate in 2005 and postgraduate in 2007. So he has 15 years rich experience in the field of structure design, has worked on projects like power plants, ports, mining, process plants, healthcare, industrial pre-engineering, building material, beachfronts and seafront developments, railway facilities projects, and most importantly, bamboo as part of structure design that can withstand in cyclone as well. Let us understand from him the success in design in bamboo architecture. Thank you so much. Yeah, over to you, Nilang.
Thank you, Architect Hemang Mistry. Just for clarification, I completed a graduation in 2003 and master's in structural engineering, civil engineering in 2005, and everything. It was good. I had experience of over 16 years of experience. Thank you for giving me the opportunity to perform over the stage and whatever the structures that we have been performed earlier for the bamboo. And start before beginning, we were very excited. I was very excited when I was started working on opportunity to have the bamboo, because that is the challenge that we are exploring. So let's begin. Let me share my screen. Okay, yeah. About me, I have been graduated in India.
Yeah, we can see your screen if you have shared.
Okay. Can everyone see my screen?
No, not yet.
No, not yet.
Okay.
Are you on dual screen?
No, I am on the single screen. Please try, like some error is coming. Let me do it again.
You are a co-host already.
Still, screen sharing has been failed. It comes with a message. Still, I'm getting the error. Screen sharing has failed to start. Please try again later.
So, Rangana, if you can just share the email ID, he'll just mail it to you immediately. And by the time, he'll just start introducing himself.
No.
Would that be possible?
Do you have the PPT? You can share it directly to Architect Hemang Mistry, please.
Sure. Yes. I'll let me do that.
Let me stop. Need to remove the host permission and give you again. Okay. Try now.
You just need to click on share content and then the file location.
I've already been done, but it's not happening. So I'm sharing a PPT as well to you. So in case anything is happening, so.
Okay.
So flow can be continued. Let me share in two different ways. I sent an email to you. Let me start again. Let me share again if it is happening. Still same error code.
Rangnath, you can give the permission to share.
He's already a co-host.
He already has, huh?
Yes. I've withdrawn and again given.
Okay.
Yeah, Nilang, it's here now. Can you see? Can everybody see the screen?
Yes, we can.
Yes.
Okay. Okay, sorry for this for this problem. Okay, now let's begin. Next slide, please. This is small about me. I have the experience in several projects in residential, commercial, and industrial project in India, as well as several countries in Europe, America, and Australia. And I had total over of 16 years of experience in structural engineering field. Next. Presently, we generally use like a normal material, that is structural steel, concrete, and bricks and aluminum, so that codes and materials are readily available, so we can use it and we can design the structures. And their joineries and their other details are already been available, and so we can study that, and we can design the structures very easily. So these are the common trends of a material that is going on in the market. Next, please. Font has been changed. Sorry for that. So the problem is, I'll continue with my presentation over here. So together. Okay, so rethinking of bamboo in mainstream. So there are certain challenges to use this material, as this material is used in several other countries and even in India also. There are certain challenges for the available resources, such as extensive studies, and so ready resources are not available. Let's say of the compressive strength and other details are available, but for the joinery, how we can design the joints and stuff like that, that is not available. So that is the challenge. And so it requires extensive study to perform the structural health overall. And there are some ways to possibility that we cannot use bamboo as a single material. There should be the possible ways that we have to integrate with other material. And that are the possible usage of the bamboo. We can integrate with other material. And so of course there are possible that we have to get it peer reviewed, and it will be required to have collaboration with the academic institutes, so that the interest of the awareness and exploration of the capacity and its potential use can be expanded, and we can see what are the future opportunities using this material. And this bamboo in our culture since so many years, maybe more than 100 or 200 years, but the laborers that they are using the bamboo that for, let's say, for the shuttering purpose, and some other in the olden in some of the areas in the Gujarat, I've seen that they are using the bamboo strips as a reinforcement. So they don't have any education how to use its material characteristics. So they are using by their own calculation, by their own hand method. So when we are talking about the advanced method, so there will be the change in the technology. So there will be change in the usage of the material, how we are integrating with the other materials. So engineering solution that we have to perform, and based on the architecture requirement. So training will be required to the labor, those who already have the extensive experience to how to use that material, but we can add on some solution to them based on the engineering solutions. But for let's say for the parametric architectures and stuff, and we have to go for the large span structures. So in that case, we have to educate them. And there are some challenges that the client inclination to use as a bamboo material. So based on the, but that will be based on the project function and usability. And normally the clients inclined to use the normal materials such as the reinforcement concrete and structural steel. But there are some possibilities we can use this material at the initial stage, and then we can enhance, we can go beyond. And for the next slide, please. So how it works. So we have to think about that. So thinking of the basics, how that can be possible. We have to come together as an architect and the engineer possibilities with the, let's say the architect has come with some of the ideas and he has to use it. So in that case, we have to integrate with the architect and the engineers together, and we have to study the available research material and other available resources throughout the world. And we have what we have to do. So when we gather everything together, we have to validate those information, and we have to generate the mathematical model by using latest softwares, and then we have to do some experimental approach for, let's say, for elemental testing of some of the elements with that early presentation that has already been there. So it was nice presentation. So we can add based on the project requirement. There are the experimental approach that we can perform based on the project requirement. And in the combination of everything, we have to collaborate with the institution, and with the peer review, we can get the final product that will be very helpful for the society. Next slide, please. So go step by step. We don't want to go for the large span structures because this is a new material. So there are two projects that we have been done in the past. That is, they are situated at the Gujarat Diu. One is the Naga Beach Development Project, and other is Gogla Beach Development Project. And first project is the Naga Beach Development Project. There are a couple of elements are there. There are several toilet hubs, and there's some varying size. Span is about 9 meter, and length is about 40 meter, and having the height about 3.6 meter. A structure comprised of the RCC foundation, side walls are stone masonry. That is the Bella stone. That is a very heavy stone. And so initially so based on the requirement from the architect, we go for the bamboo structure as a roof element, both in the toilet hub 1 and toilet hub 2. And there are so many food stalls that we have to that they have to construct. This is basically the government project, and its plan size is about 3.6 meter by 3.6, and having the height of 2.5 meter. Roughly 15 numbers of food stall has been under operation since 1 year, and others are under phase-wise construction. Substructure comprise of the RCC foundation. Side walls are masonry wall, stone masonry, and roof is a bamboo structure. There are a couple of other elements are there, but they are not from the bamboo, but they are based on the requirement of the project, like retaining walls and other structures are there. Next slide, please. This is the architecture layout for the toilet hub 1. Next slide, please. Just highlighting what are the elements for the bamboo toilet hub 1. Next slide, please. Roof. I don't know why presentation. Everything is stretched at your end. Mine is completely good. Let me try my screen sharing because it doesn't look good. Can I share my screen? Because I am reading from my presentation, and when I suddenly look at your presentation, it's completely different. It's very stretchy, and it's still same error I am getting.
I think we have some time. Probably you could log out and log in to me.
Yeah, I'm just sharing from my other PC. So just give me a minute. It will be resolved.
I'll also share the PDF copy. So I think that will be better because completely different. So it's not syncing with the communication.
Rangnath, can you make architect Hemang Mistry on the co-host?
You're already a co-host. I think the best is PDF.
Yeah, I'm making the PDF. It's 53 pages. It takes some time. So I apologize for this problem.
Rangnath, there is another architect Hemang Mistry. So you can just make that the other one, the co-host. This the other one because Sthapatya Rachna.
Sorry, what is the name?
Architect Hemang Mistry.
Yes.
Sthapatya Rachna. Yeah, please make that co-host.
Yes, done.
Yeah, it's better to show it like this, I think. And just scroll down in this and see whether it is.
Yeah, it's good. Yeah.
No,
Okay.
no, let's go to the page where the, yeah.
Nilang, is it okay now?
Yeah, it's okay,
it's
but
fine.
I don't know how much that people grab from the other sheet, other pages. So if anyone adds want, then I can start again, no problem. Because there are some key elements. It's okay.
This is you can just go ahead with this, I think, Nilang.
Okay. Yeah, sure. As we discussed, there are a couple of elements out there in this first project. So this is the toilet hub one. This is the architecture layout drawing, and there are a couple of small elements out there. Next slide, please. This is the plan area of the structures. They are staggered. This is the first one. Next slide, please. This second and a small one. Third one. Yeah. Go ahead. Next slide, please. And this is the roof layout of the which is made of the bamboo. And next slide, please. Here's the toilet hub 2 that is situated at the same site but at different location, and its geometry is different. Next slide, please. Next slide, please. Okay, and this is the ongoing situation of the bamboo structure. Roof is made of the bamboo, and it will be the curved roof. So so first of all, we don't want to make geometric complicated. So based on requirement from the architect, we discussed so many options that how do we go with the bamboo, because if we go for the straight element and combine with the horizontal, then it will create a problem for the joinery. So we go for the curved roof, and so this is the frames are spaced at about 6 meter to 7 meter spacing. And next slide, please. These are the other side photos. Next slide. Next slide. Detailing of the foundation. Here we have the situation that possible scouring at the base, and there will be this possible settlement of the structure. So we consider this scouring depth, and as the structure is having the lateral force due to the wind, and there will be the uplift of the structure. So we check the foundation with all the potential gravity load of the masonry wall. And we consider the strip footing because it has the potential settlement. So individual footing will going to be problem. So we consulted with the geotechnical consultant. So based on that data, we provided this strip footing, and this is not the heavy high-rise structure. So this is a very lightweight structure for this footing intended use. So we go for the strip footing. Next slide, please. And there are these are the structural details for the foundation, and there are two different options. One of the locations where we are getting soft rock, and we have to integrate with the foundation because there are possible chances of the slidings because of the smoothing surface. And so we next slide, please. So we provided a rebarring of the at the rock with the foundation, and for the joinery with the connections with the bamboo element, we provided the reinforcement within the bamboo, and also provide the micro concrete within its hollow bamboo. So we can smoothly transfer the force, because when we check the forces, reactions are within the limit of the shear stress, but sudden change of material from one parameter to another parameter, and the integration with the foundation, we use that technique. Next slide, please. There are some details out there. I'll show you. And while this is the structures under construction, we have some problem that we are getting. That 2021 we are getting there, and the structure is initially intended to design for 60 meters per second of wind speed, and and we have the 200 kilometers per hour wind speed at 250 kilometers per hour wind speed that is occur, and it's lasting for 9 to 12 hours, hitting directly to this coastal area, and starts from Dev itself. And there are so many damages over that region. So it was very difficult situation because site under construction, and there are some problems that we get as it's under construction. Some roofs of this particular structures has been little bit collapsed. So we try to provide remedies for that, and we also measure what are the other structures had been, what was happened to the other structure. There are so many damages that is occurred at this southwestern coastal of this particular area. Next slide, please. So if you look at this picture, there are very near one of the near the region, there is some damages out there. So just for the intensity, there are so many information available, so I don't want to go for that. So this is only one image that I just placed. Next slide, please. So for the remedies, as I introduced earlier, that bamboo can be we can use for as an independent material, and we are using the curve geometry that is the best for making the smooth transferring the force, and the dome and the structures like that. That is very easy. That we can control the thickness But here we have situation that this is very high intensive wind pressure was there. Again, it was lasting for so many hours was there, and it is possible that that will be hitting at every year. So we have been proposed some modification. So what we have been done, we introduced, we haven't modified the structure a lot. We introduced the cable at every frame, and we also provide the bracing over the roof. So any and all the cables are not under huge tension. It's just localized pre-tension and allowing about 10 millimeter of deflection. So whenever the wind is going to be hitting over the structure, cable will going to be engaged with the structure, and it has already been engaged. So there are Can you go for next please? Yeah, this is the cross section detail, and we provided cables at the backside of the arch. Next slide, please. So go back to the previous one. Sorry for that. Go back to the previous one. Yeah, if you look at this particular arch, we have been provided angles and the small little framing, and we also provided the localized pipe that is welded with the angle, and we haven't pressured more over the existing bamboo, because as if we make some additional pressure, and the bamboo will going to be have the bearing issues over there. So and at 1200 spacing, we provided this particular detail, and we run the cable starts from one end to the other end, and we modified the existing RCC pedestal to integrate with the entire system, and we introduced plus shape shear key, and that will going to be under action when any uplift of the structure will be occur. Next slide, please. These are the details of that particular cross section that I was talking. If you look at this particular dot, these two rods that is running throughout, cables are running throughout based on the geometry, and and this particular plus shape plate that we have been introduced. So it will we have checked this their welding capacity over there, and also check the lateral force and the moment and shear over there, and we also check the transfer of the shear over the concrete. Next slide, please. And we see we cannot do directly provide the hole into the existing column and run this detailing. So we provided additional concrete to integrate with the structures, and certain rewiring that has been done. We also check for the shear friction for the additional reinforcement to integrate with the structure. Next slide, please. There are other structures, food stalls that I was already again talked earlier. That is 3.6 meter by 3.6 meter in plan view. That is initial idea was to have the cantilever structure, and as a structural engineer, I have been resistant to perform that part. But project was already been in the motion mode, and there are some of the elements that has been casted. So structures has been designed for all 4 points supported. And next slide, please. Go back to the previous one. Sorry for that. If you see the detail of this particular column and the bamboo chair junction detail, we provided details for the reinforcement that is going through from the bamboo, and micro concrete has been placed over the bamboo by providing the hole over it, so to integrate with the system. But if we are not going to provide like that way, in that case it will easily dislocate from the system, because it creates a small gap around it. So we try to integrate with the system. Next slide, please. There are some of the options that dual food stalls were there. Next slide, please. This is the detail for the upper part where we provided the support at the peripheral edge of the wall of the food stall. Next slide, please. This is the modification detail that we have been performed. We provided the rebarring over the graded slab, and small corner columns has been initiated over there, and we provided a bamboo support over there at this particular hatch portion. Next slide, please. This is the detailing for bamboo to be integrated with the system. Next slide, please. This is the ongoing activity over the site. This is the earlier version of picture when the site was ongoing. Next slide, please. This is some of the closer look after the finishing. Next slide, please. See, there are a number of columns that we have been added over there. And next slide, please. And while this incident was happened, there is no damage over any of the structure, except one tree was fall down over the structure, and that caused the damage. Next slide, please. These are some of the additional views. Next slide. And there is another project that we have been done, and it is also going on. That is the Gugla Beach development. It is the same situation where the cyclone had hit. There are a couple of elements are there: Watchtower, entrance later. There are very small elements are there: spiral entry. And there are some of the amphitheater structure that we have designed, but that has been cancelled out. So I haven't included over this presentation. So it is not present over there. And Watchtower size is about 9 meter by 40 meter. Sorry, I think this is wrong. Next slide, please. It's about only 4 meter by 4 meter circular diameter, and about 6 meter height. 6 to 8 meter height, and it comprises of the dome over the roof, and it has the platform. It's just a watchtower. People can come in there and feel it at the side. And here at the dome, there will be force over the ring. So we initially intended to use structural steel ring, because that was the intention. But unfortunately, there are some pressure from the requirement. So we have to use the bamboo as a structural element. So what we have been done, we have been used the bamboo as a dome, and one frame starts from the one support to the other support, and all the other frames are come together, and we have filled with the bamboo elements, and diaphragm plate we have been provided, and screen plate that is we have been provided. So all force can equal out together. It will be transferred together. And this is the platform entirely made of the bamboo, and all the elements that we have been checked based on the geometry that we have been creating in the stat using the stat model, and a compressive strength and stuff like that. There are some guidelines are available in the code that we have been follow. Also, we also check some specimens to check with the compressive strength of the element, and we also take some specimen for tensile test. Next slide, please. This is the outside view of the watchtower. Everything based on using the bamboo elements. Next slide, please. Next. At the entrance, there are some ladders. This is not very much big structure. It's very just ladders. Everything is from the bamboo, and supported over the RCC beam and the column, and the foundation RCC foundation. We have checked with the torsion and everything. This is very light load. Next slide, please. And one other interesting project that we have been performed near to Bharuch, at Riverfront Meditation Hall. It's about 50 feet wide span and 120 feet long span. So it comprises of, let's say, if we compare this particular structure. So what we have been, we are doing initially, whenever the structure comes and we compare with the existing material, existing technique, and we integrate with the bamboo and their capacity. And initially we check with the other material. Let's say if it is made of the structural steel, then what will be the behavior? If it will be based on the wood, then what will be the behavior? So based on that, and then we found that with the bamboo there are possibilities, but in that case we have to be conscious about the structural system. This is a 3D view of that particular isometric model, rendered model. Next slide, please. This is the erection, site erection activity going on, and vertical column internal supports are already been provided. Next slide, please. This is the ongoing activity. While we are model the structures, initially we thought to have bamboo element as a cluster of bamboo as a main raft member and the column, but it comes out very heavy and make the structures very heavy. Even though joinery at the beam column junction doesn't allow to have the rotation to be because if we add some additional joints over there, because it creates a stiffness loss of the joint, and it creates a problem. So what we have been done, we introduced the brace and ease out the system. So deflection was controlled and force transfer was smooth, and the entire system were carrying the very light loading. Initially, when we thought that if we let's say if we make the common way, but that is not possible. Connection doesn't allow it, and if we make that kind of connection, that is not possible. In that case, we have to use a structural plate, and how to integrate the plate with with this particular bamboo element. That is itself is another challenge, and itself is an extensive study that we have to do. So in that case, that would be non-linear behavior between the two material, because bamboo itself have the nodes are there, and there will be some issues with the material. So when we introduce the brace and we take out the forces from the system, that is comes out very well. We check the deflection over the side, and everything is completed over the side. Next slide, please. These are the other pictures of the same site. Next slide, please. Next slide, please. This is we are just now started working on one of the project. One of the architect that has come to us, and he need to go for the parametric design. So they give the sketch and the 3D view, and then we started the discussion that how we can do that. So is there any possibility with that? So this is the initial discussion, and based on that, we have been started working on that, and we provided the solution how to work with the system. So next slide, please. This is the basic model based on what we have been got from the architect, and then we collaborate with the architect. What are the solutions that we can make? So next slide, please. We discussed with the architect that there are the possibility that we can go for structural. That structural engineering starts from whole to part and part to whole. Let's say for the FE analysis, or maybe stiffness matrix analysis, or even though if we start from transferring the load from superstructure to the foundation. So we discretize the structures in different framing. So we give the options that we can go for the several framing system to add on the trusses. So by the color gradation, we added the framing system. There will be some problem with the integration with the system. So we are working on it. So this is the first cut option that we have been provided, and roof size, roof height may be going to be increased because the truss will be, which truss will be this lower one, which truss will be the upper one. So that we are working on it. And we have initiated the discussion. Then we tried to figure out the situation, and there are the possibility that we can go for the cluster of the bamboo elements together instead of the trusses. So everything that we are performing over here. Next slide, please. This is the system. This is the initial system that we are creating, and we are also collaborating with the institute. We already have the talk with the several institute in Gujarat, that they are going to support us for this particular project for the peer review. We are also willing to go for not only to make the model, as I already been mentioned in the earlier presentation, that we don't have to just use the sophisticated software and make the model. We have to validate that particular structure by making the small prototype structure that we are interested to move ahead. And there will be possibility that we can go for testing of the structural element. Let's say not for only the bamboo small part of itself, but real, let's say the arch. We are go for this. This structure is comprised of about 84 feet of span and about 120 feet of length. So it's huge span, and we don't want to make any mistake, and we don't want to take any risk, because connections and the stuff like that, we don't know what will the behavior. So there will be possibility that we will going to go for the testing of this particular structure once the project will be going to be under action confirmation from the client. And client is also interested, and we already been discussed with the options and preliminary first cut costing. And we also introduce the customer, that sometimes the customer comes us and client says that I don't have money to spend for the testing, but the structures like that has to be make the serious attention. So we are trying to make it possible, and we are interested for those customers who are enthusiastic for such kind of elements can be utilized. Next slide, please. This is all about my presentation. I hope that add the value with the society, and I may also get the feedback from you. Thank you.
I think, Nilang, there are a lot of efforts being kept inside the project. A lot of ifs and buts being discussed. It seems there is a rigorous process being done while the project was working. So I would like, if anybody would have any queries where Nilang can respond to it.
Nilang, presentation was very wonderful. It was a very interesting thing. I was very curious to know what kind of bamboo you would be using in your project. Are you very specific to one, kind, or multiple kind of bamboo you will be using?
Presently, we are using the bamboos that is manufactured, that is from the Assam, and also available from the Goa. But most of the bamboos that we are using from the Assam, and we get the information from the vendor. They are very expert for selection of the material, and we get the information from them. And all the bamboos are tested and dried very well.
Thank you, sir. And another question is, when you're designing a tower, right? I see you designing a tower, so which was totally exposed to the sun and rain. Is that the tower is built for a temporary purpose to showcase something, or just it's nothing wrong in it? Just want to understand.
No, this is not a temporary structure. That is a permanent structure, and it's nearer to the seashore. And there are so many studies has been done that when the structures with the this kind of bamboo elements, it's good near to salty environment. It won't be any problem with the bamboo. It won't going to be deteriorated.
Thank you, sir. Your projects are very nice, especially the toilet project. and towers, and I believe this presentation completely on structural, but all the projects are very interesting. Congratulations, sir. Thank you very much.
Thank you. Thank you.
There seems to be a lot of interest in the toilets, definitely. But nevertheless, Nilang got some fantastic presentation. I'm keen to see how this can be duplicated. Can you make some kind of a franchisee model for the toilets and sell this? I'm sure a lot of people will be interested. No, I'm not joking. On a serious note. Looking at highway transportation, a lot of people need that comfort factor. And if we can build a model, commercialize it as a package, and then sure there will be private companies who will come forward to take it and implement it on a BOT basis, right? So explore this, please. And I think that will be a way to promote bamboo. People will definitely, especially if you look at the highways right now, there are a lot of restaurants on the highway where you can take a break. Okay, and these areas, if you can showcase, especially create a model saying that give me X amount of space, and this space I will build everything and run it, and you charge the people. It will be a 24/7 outlet, and even assuming if we have 5,000 people coming in a day, passing by, that's your ROI is going to be quick.
Thanks for the advice. Thank you. Actually, we were also thinking about starting the startup, because let's say last project that have been defined, there are possible that there will be some investment that won't be possible from the customer itself, but we have to investigate the structure. So in that case, if you go for the startup, and Startup India is giving so much of support, Government of India is supporting so much. So we are thinking in that direction. So I think it's good idea that you are giving us some this one.
The key here is create a showcase model, and then one showcase will be good enough, and then you can see it's like a McDonald's franchising. Right? So that is the key. If you have a project plan, I can help you find an investor.
Sure, we'll approach you, sir.
Thank you.
Uday, sir, any of you would have like to share anything?
Yeah, I just wanted one small. So Rangnath, I have a model, and for a folding toilet unit, it's also got shortlisted for the Red Dot Design Award. If you can get me a person who wants to take it forward, I would be most happy to. From CGBMT, we have developed a model as per the Swachh Bharat thing. It's a folding toilet unit. So if you can get somebody, we will be happy to disseminate it.
You will study this and you can take it forward.
Good.
Yeah, definitely. I have one question for Nilang. What is it that you have done about, you told that nothing will happen to bamboo if it is exposed. I have a little doubt about that. So I would like to know, to protect it, what is that you have done to protect so that nothing is going to happen to bamboo or it not deteriorate? If you could share with us.
Okay, first of all, we use this treated bamboo, and for that thermal protection, I don't have the handy material because there are so many things to showcase you. So I can share with the email with you. To protect from the temperature effect, there are possibility that at the over of time, maybe 4 to 5 years, there will be some regular interval of treatment that we have to do, so we can protect from the thermal expansion and the temperature variation, because there are some possibility that may happen over the time because of the our climate situation. But for this specifically structural, what we have been done, we haven't gone for 100% utilization of the elements. Let's say as we are designing the structures for the structural steel and RCC, structural steels, when we design the structural ratio, we talk about the structural ratio, we go up to 90% in some cases, and up to 1% maximum to 95% of capacity and up to 100% capacity. Here we limit our capacity. We don't go beyond 50%. So that's, let's say we required the bamboo about 4x4 numbers of cluster. So we provide the 3x3 number of cluster. So that way we can cover up some space. So for the capacity itself.
No, I am talking about bamboo exposed to the elements. Yeah. That is what I'm talking about, because as far as I know, and I have been in this sector for around 23 years, but we have architects like Simon Velez, who has been in this sector for more than 45 years and more. And according to them, bamboo does need a boot at the bottom and a hat at the top to actually, because it's a natural material, like any other natural material, you are supposed to protect it from the elements. Otherwise, its life does get severely actually affected.
Okay. Now I got your point.
We are talking about the cover.
Sorry. For the cover, that I clarify you, for the temperature variation with the roof at the head, for the head, and for the boots, we, as I discussed earlier, we provide reinforcement, but that doesn't serve the purpose that you are talking. That I understand. So we provide, we painted with the bitumen paint at the base, and then we utilize for the integration with the concrete.
So I think
I'm talking about the top cover.
Be able to answer on this.
The top cover I'm talking about.
Yeah, so I'll be able to answer on this. So these are basically all the projects which we have done collaboratively on this. So yeah, so there is one bitumen layer on the roof. So there are 3 layers which have been implemented on the roof. One is the first one is the flattened bamboo roofing, the cover, and then there is a bitumen sheet which acts as a waterproofing layer also, and also as a weather protection. And then on the top there is another layer of flattened bamboo. So seems your mic is on mute.
I am saying what happens to the flattened bamboo on the top.
So what we have done is we have coated melamine layer to it.
Okay.
Yeah. So that helps the resistance to the atmospheric reaction to it. Yeah. So it becomes more as a solid material than exposing to the natural material.
I have a question. We talked about the bamboo that treated. What kind of treatment process?
So this is CCB treatment.
CCB, okay.
Yeah. And then after the treatment, one, there is a starch being removed from the bamboo, and another is the boron with the help of the CCB chemical, yes. So I think this becomes, so these institutes which we are working with, so it's a CIBAT, and what they have done earlier is they have kept non-treated bamboo in the land and treated bamboo in the land. So they've grouted inside. So after a year, they found that the treated bamboo was as it is, and the non-treated bamboo was totally eaten up.
Yeah.
So we've been doing these experiments at regular intervals to protect. And of course, there are these then melamine coating, which is done on each bamboo before the clustering is done.
Okay, because this flattened bamboo roof that is there in a climate like Bali, every 3 years they actually change, which is a very expensive affair.
Yeah.
And all the Bali buildings that have been doing on the internet that you see have to be changed every 3 years. and the way they keep their coating, the coating is also pretty expensive. So when we talk about using bamboo for the masses, it becomes a little bit of a thing. So I'm just concerned about all the time about bamboo using for the masses. So that is where these questions come from.
The majority of these structures have lasted since 2 years now. And we saw there is no transformation on this structure which has happened. Any of this fungi also was not seen on these structures. So we've been constantly noticing these structures at regular intervals. So probably after 2 months of the monsoon, which has been passed. Because in monsoon, majority of these fungus, they start evolving because of lack of sunlight. So even these the structures which you can see in my background. Now this is 2 years old. So none of these structures have formed any of the fungus formation or any of these termites as well.
Yeah, they don't. Once you treat them, they don't.
Yeah, exactly. So even the roofing is being treated. Even all the flattened roof is also being treated with CCB treatment.
Okay. So yeah, we will be, it will be good to keep sharing these things because to take things forward. So, and we have the dialogue going so that people, if they have any questions and any doubts, they can come forward with them, and then the industry can evolve further.
So I'll just share two images of how the treatment is done. So this is the tank where the pressurized treatment is done. Yeah, so you can see these stacking on the right side. These are all flattened bamboo. So even those are also kept inside this tunnel and being treated.
Great. Thanks.
Yeah. So any more questions for Nilang on part of structure design?
No, actually, I want to give a tips to Nilang sir. As Ranganathan sir said, there is here the Buckins. In US, the famous toilet project is Buckins. Everywhere, every tool has it's a free toilet. People will rush, but they're making a good business in Buckins. That's a tips for Nilang sir. You have a good opportunities.
Thank you.